Okay, now we're recording global warming. We said the causes of global warming, natural effects like the sun energy on Earth, the Earth configuration like its tilt with respect to the north, carbon dioxide in the atmosphere due to respiration, volcano emissions of carbon dioxide, and the burning of fossil fuels are all causes of global warming. Respiration, living creatures like animals and humans and so on, they take in oxygen, they give off carbon dioxide, while plants do the other way during the day. Warming periods are associated with high carbon dioxide levels and vice versa. And we said that natural mechanisms for keeping carbon dioxide in check. Nature has taken care of itself over the long past. When the atmosphere gets too hot, there's lots of rain which dissolves this carbon dioxide. So this is the carbon dioxide natural cycle. We said that volcanoes emit carbon dioxide, rain dissolves it. We said that rock weathering absorbs it. So this is calcium oxide plus carbon dioxide gives calcium carbonate. Okay, so this calcium carbonate comes down in rivers and carry it to the ocean. Then in the ocean sedimentation, this stuff falls to the bottom of the ocean. Then, if you remember plate tectonics, subduction melts the rocks because when it gets too deep, it's very hot. They silicate these rocks, they melt, they form magma, which gets stuck in the magma chamber for a while. When the pressure builds up, magma, there's a volcano eruption, magma becomes lava, and volcanoes emit carbon dioxide for another cycle. Okay, so this is natural carbon dioxide cycle. And let's talk about scientific evidence of global warming. So we said isotopic evidence of global warming in ice core studies. Isotopes are elements that are slightly heavier. Like for example, the deuterium isotope, the deuterium is an isotope of hydrogen, but instead of mass 1, it's mass 2. It has a 1 proton and 1 neutron. So isotopic evidence of global warming will explain. So water evaporates at 100 degrees C, while heavy water containing deuterium, slightly heavier than hydrogen, evaporates slightly higher temperature. So the warmer the atmosphere, the more it contains heavy water. Okay? So the warmer the atmosphere, the more snow contains heavy water. Snow and ice and so on. So snow has been falling in the Arctic and Antarctic for a long time. It's just like a record. So mapping out the heavy water profile yields the past temperature profile. The deeper in the ice core, the farther back in time. So analyzing carbon dioxide content in bubbles trapped in the ice yields carbon dioxide content over time. So you drill a core from the North Pole or the South Pole, deeper the farther back in time. Then heavy water content gives you the temperature, and the air bubble give you the carbon dioxide content. So this is, for example, result going all the way back to 400,000 years ago. This is carbon dioxide level in ppm, 280. It's increasing. Now it's slightly over 400 parts per million. This is the carbon dioxide, this is the temperature. They go hand in hand. When the carbon dioxide level goes down, the temperature goes down, and vice versa. And there were many, many global warming and global cooling periods in geologic history. Okay. They correlate very well. Okay. There's another variation up to 100 million years ago. This is 100 million years ago. So we said the global temperature dropped by as much as 8 degrees C over the past 100 million years. So it used to be 23 degrees back 100 million years ago, and now it's around 15 degrees C. Okay, so we said carbon dioxide levels have come down by a factor of 10 over that period, from 4,000 ppm down to 400 ppm over 100 million years. We said the Cretaceous period, 145-65 million years ago. This is the last period of the dinosaurs. So a decreasing level of volcanism, 145-65. 65 is here, so this is it. So less volcanoes, so less carbon dioxide, produce decreasing carbon dioxide. The variation of the carbon dioxide concentration, parts per million, and relative temperature change in the past 100 million years. Okay, so this is another view of the table. The eras in geologic history, the eras are here. Era of the vertebrates, 540 million years ago to 250 million years ago. Era of the reptiles and birds, including the dinosaurs, 250 million years ago to 65 million years ago. If you remember, 65 million years ago, the dinosaurs got wiped out. Most of them died. And then from 65 million years ago to now, era of the mammals. Okay? There were some global warming, global cooling, and so on, up to now. All right. So the last one was a global cooling. It was full of ice. Earth was full of ice. United States was full of ice. Global cooling, 1.8 million years ago to 10,000 years ago. Global cooling. And now we're in between. Global warming, global cooling, and so on. Not to mention the fact that before 540 million years ago, there was only unicellular life, so there was no bones, no hard shell. We don't have fossils. We don't know a whole lot about history. Anyway, this period from 4.6 billion years ago to 540 million years ago, this period, we don't know a whole lot. There was a lot happening. First, there was a formation of the solar system, a lot of bombardments and lava and so on. Nasty. Then there was these volcanoes that emitted a lot of carbon dioxide. Earth was full of carbon dioxide, no oxygen. Then appeared what I call cyanobacteria. They absorbed carbon dioxide and gave off oxygen. Then life started thriving, leading to what is called the Cambrian explosion. Explosion of life, bursting of life. Everything appeared. All right. Then life was in the ocean first and moved on land and so on. Anyway, so past carbon dioxide levels, we said 3.3 million to 3 million years ago, saw a 2-degree temperature increase on Earth. The Greenland ice sheet had melted and the sea level had increased by 25 meters compared to its current level. Okay, 2 degrees C gives you that much upheaval. Basically the North Pole, the South Pole melted. We said 2 million years ago to 12,000 years ago. Here was global warming, here was global cooling. So the oldest period in Earth's history, ice sheets covered continents with maximum glaciation some 14,000 years ago. The sea level was some 120 meters below the present level. Okay, so this is here, Pleistocene, and the Holocene. Okay, mid-Pleistocene and the Holocene. Okay, so isotopic evidence for climate change. We said that heavy water evaporates at higher temperatures than normal water, evaporation. We said higher atmospheric temperatures means more heavy water at the North Pole. We said keeping track of isotopic abundances in the Greenland ice sheet, in air bubbles, determines atmospheric temperature and carbon dioxide composition. We said keeping track of isotopic abundances in seashells at the bottom of the ocean helps determine ocean composition. So ice core studies at the North Pole and bottom of the ocean core studies as well. We said isotopic evidence of global cooling and warming trends. The Greenland ice sheet contains record atmospheric temperature. Ice core studies from the North and South Pole agree about past temperature and carbon dioxide contents in the atmosphere. These are ice core studies, and these are ocean bottom samples. Keeping track of isotopic abundance in seashells at the bottom of oceans help determine ocean composition. They all agree, North Pole, South Pole, bottom of the ocean. Scientific data agrees. We said that ice cores and deep sea sediment cores contain a time record atmospheric temperature. Result of these are consistent, they agree. Recent warming trends. Burning of fossil fuel produces carbon dioxide, this is greenhouse gas. This gas has been sequestrated in coal and oil deposits for millions of years. So you see more and more carbon emissions, carbon dioxide emissions, and right now it's around 8 billion metric tons. So we've been emitting due to the burning of fossil fuels. We said that cement, this is, most of it is due to petroleum, coal, and natural gas. Cement contributes slightly to the emissions of carbon dioxide, about 5%. And we've been monitoring carbon dioxide levels have been ongoing for 50 years in Hawaii. Okay, so the shrinking coastlines over the years because of rising sea level, increasing flooding and so on. And the North Pole has been shrinking, 1980, 2012. So carbon dioxide survey. The red spot is more carbon dioxide, 400 ppm or higher. See that industrialized nations produce a lot of carbon dioxide. This is another view from what is called Science Sphere. It's a software based on real scientific data on NASA and NOAA satellites. And you see that it's getting redder. 400, higher than 400 ppm. As a summary for global warming, we said amount of greenhouse gas in the atmosphere determines the level of global warming and cooling trends. There is isotopic evidence of global warming and cooling trends caused by natural phenomena in the distant past. Volcanic eruptions released a great deal of greenhouse gas. There is evidence of multiple global warming and cooling trends in the geologic past. More recently, the last 100 years, in other words, since the Industrial Revolution, excessive burning of fossil fuels increased carbon dioxide levels to 400 and slightly over 400 ppm. This increased the global temperature by close to 1 degree C. Global warming mitigation involves burning less fossil fuels, coal and oil, and producing more renewable energy like hydroelectric, solar, and wind energy. Thank you.